Hi, and welcome back. We are going to talk about section 5.3 as we continue our discussion on polynomials. We are actually going to jump into multiplying polynomials for this lecture. Okay, so the first thing is, whenever you're looking at multiplication, you know if you have one term multiplied against another term, what to do. But we're going to extend that thought just a little bit by looking at how we multiply monomials first. So monomials, I have negative 2y cubed, and I have negative 8y to the fourth as my first example. Now, if you have your exponent rules handy, this is where you want to use them as you're going through practicing, because exponent rules really play a lot into the idea of, or the concepts of using and working with polynomials. So that being said, let's jump right in. So I have negative 2y cubed, negative 8y to the fourth. Go ahead and multiply your coefficients. That's negative 2, negative 8 is positive 16. Y to the third and y to the fourth, you have the same base of y. Remember, this is your product rule. You add 3 and 4 to give you 7. And so you have 16y to the seventh. Pretty straightforward. Now, as you would do this next one, you're going to follow pretty much the same exact suit. You have 5m to the third times 5m to the third. Oh, that's a 3. There you go. Coefficients, you get 25. M, 3 plus 3, you get 25. M to the sixth. Now, this next one's a little different. You'll see why in just a moment. Nothing you can't handle, though. Definitely nothing you can't handle. You've already worked with these in the past with exponents. Okay, very good. Now, we have 3y to the second, z to the third. That's our first monomial. We are multiplying against 6yz to the fourth for our second monomial. Coefficient to coefficient, so I have 3 times 6 is 18. Y to the second times y is y to the third. Z to the third, z to the fourth is z to the seventh. So even though you have multiple variables, don't fret, just take it step by step. Let's do another one. Monomial multiplication is super quick because it's very intuitive to what you've already been working with, both before this class and throughout this class. Oh, that is 3, there we go. So I have negative 4m cubed times 5m squared, just making sure again that I have written it exactly as needed. So coefficient to coefficient, negative 4 times 5 is negative 20. M to the third, m to the second, that will become m to the fifth. So again, these are very straightforward. They're very easy to work with. Let's do one last example, and then we'll jump into a different, slightly different concept. An extension, if you will, of this thought. All right. So I have negative 12, negative 9. Sorry, I'm reading this out of context. I have a negative 12 r to the fourth, s to the seventh as my first monomial. Negative 9r as my second monomial. So as you go through and you look at this, coefficient to coefficient, notice you have a negative and a negative. So just like before where you had negative and negative, you want to make sure you multiply those and get positive. Don't lose your signs in the process. 9 times 12, if you're popping it into a calculator, that's perfectly fine. If you're just doing it in your head, that's fine too. You should be getting 108. 108. R to the fourth, R, that's R to the fifth, S to the seventh. Okay, so that's monomial times monomial, one term times another as you go through your multiplication. Now, to extend this thought just a little bit, if I were to take a monomial and multiply it against a binomial, something like 2x times a negative x plus 5. So I have a monomial, that's that 2x, times a binomial, that is the negative x plus 5. What I'm doing is I'm distributing my value. And you've already worked with distribution in the past. You're probably very familiar with it. But I'm taking this entire term of 2x and I am distributing to each value in here, in my parentheses, or inside my quantity. That means 2x times negative x, I should get a negative 2x squared. 2x times 5, I get a positive 10x. Now, you should always check to see if you get any terms throughout this entire process that are like terms that can be combined. Remember that is x squared and that is x for each one of those terms respectively, and they are not like terms. So that is as simple as that gets. Let's try another one just to see how this works with another polynomial. So I have 3p squared. I am multiplying against 5p cubed plus 2p squared minus 7. So I have a monomial times a trinomial, just to give you that insight. Now, we're going to do the same exact thing. We are going to distribute this 3p squared term to each term within our polynomial. And so as we do that, 3 times 5 is 15. That's p squared, and p cubed is p to the 5th. 3 times 2 is 6. P squared times p squared is p to the 4th. 3 times 7 is 21. That is a negative, so that's minus 21 there. And then times, there's nothing out here, so that's going to be a p squared. Again, no terms that you can combine, so that is all. Now, as you're going through multiplication, especially in this section looking at polynomials, you might encounter another type of example where you have a binomial times a binomial. Now that process is actually very, very simple, and there's two different techniques that you can use. I'm going to show you the first one based off of distribution, which is what we have been doing. Now in this first example, I have a binomial 4a minus 5 times another binomial 3a plus 6. I'm going to use the distribution method just to show you how this works mathematically. And then I'll show you a shortcut method as well. The distribution method, I take this whole quantity term and I distribute it to each of my values within the other quantity, within the other polynomial. That means I would have 3a times 4a minus 5 plus 6 times 4a minus 5. So again, all I've done is I've taken this entire binomial, this entire quantity, and I have multiplied it to each individual term. Okay, so there's my 3a times my quantity, there's my 6 times my quantity. Now what I need to do is go back to what I was just doing, monomial times binomial. So I'm going to go ahead and distribute again. You might have heard this as the double distribution method, and that is perfectly fine. It's perfectly acceptable to understand what we're looking at. So 3a times 4a, I get 12a squared. 3a times negative 5, I get negative 15a. 6 times 4a, I get a positive 24a. That's an a. 6 times negative 5, I get a negative 30. Now, remember what I said just a few moments ago. You should always check to see if there's anything else that can be combined. If you can combine it, do so. If you can't combine it, leave it alone. In this case, 12a squared, I have negative 15a, a positive 24a, and a negative 30. These are like terms. So I can combine those like terms. So I have 12a squared, nothing happened there. Negative 15, positive 24, that works out to a positive 9a minus 30. Okay, so at this point, there's nothing else to do. This is your simplified expression. All right, now I'm going to work the same exact problem, but using a different method. And you may have heard of this method as FOIL. It's also listed on your notes. So as I look at this problem, just making sure I have it written correctly, one thing that you know about this particular problem is that yes, you could distribute. We just did that process. Or you could use FOIL. FOIL is an acronym for first, outer, inner, last. Here's how it works. I take the first term right here, and I distribute this term to the first, to the outer. So that's 4a times 3a plus 4a times 6, just to capture that idea. This is first, outer. Then I take this second term and distribute to the inner and the last. So what does that mean? Well, I have negative 5 times 3a, negative 5 times 6. This is my inner and my last. Hence, you get the acronym FOIL, first, outer, inner, last. Simplifying each one of these components, I have 4a times 3a is 12a squared. 4a times 6 is a positive 24a. Negative 5 times 3, I have a negative 15a. Negative 5 times 6 is a negative 30. Again, always look to see if you can combine. These are your like terms in this case. And so I have 12a squared plus 9a minus 30. Notice it's exactly the same as the double distribution method. Now, FOIL, I have to be very, very clear for a moment. FOIL only works if you have the situation of a binomial, meaning two terms, times a binomial. So you have to have this exact kind of setup where you have two terms times two terms. FOIL does not work beyond that. There are some variations that kind of stretch beyond that, but FOIL itself is a special case of binomial times binomial. The distribution method will work no matter what size the polynomial happens to be. Now, that being said, as we start getting into larger polynomials for multiplication, I will stick with distribution. Whenever we encounter binomial times binomial situations, we will then use FOIL, just to keep us fresh on both methods. Okay, very good. Let's do one more, just to do the FOIL process. And I'm going to get my board space back. There we go. Get my marker capped again. All right, so I have 2x squared minus 1 times 7x plus 6. So again, this is a binomial times binomial kind of situation. And so what I will do is I will then multiply using FOIL. So I have 2x squared times 7x. That gives me 14x cubed. 2x squared times 6, that's a positive 6, positive 2, so that's a 12x squared. Negative 1 times 7x is a negative 7x. Negative 1 times 6 is a negative 6. Ask yourself if you have anything else that you can combine. This is an x cubed, x squared, x, and a constant value. So there's nothing that can be combined here. You are done. Okay, let's jump into a slightly changed kind of problem from what we were doing. I'm going to erase this. That way I have my board space, because this problem can get a little long if you look at it. I have 5a cubed minus 6a squared plus 2a minus 3 as one polynomial multiplied by 2a minus 5. Now, as I'm looking at this problem, I have a polynomial, the 4-term polynomial right here, multiplied against a binomial. Now, in this situation, this is where, again, FOIL does not really apply. There are variations, don't get me wrong, but FOIL does not apply here because it is not a binomial times binomial situation. With a multi-term polynomial and a binomial, what I'm going to do is I'm going to distribute. That distribution method always works. You just might have some extra steps. So I'm going to take this entire polynomial and I'm going to distribute it to each term. That means I have 2a times my polynomial, 5a cubed minus 6a squared plus 2a minus 3, minus 5 times my polynomial. So I have 2a times the polynomial minus 5 times the polynomial. That is my structure here. Remember I said at some point that you want lots of space. Make sure you have lots of space. These are great to work with vertically. I don't suggest going horizontally, especially in multiplication, because it is a little bit easier to see line by line what your steps are. Okay, here we are. We're going to go ahead and use some space up. So I'm going to distribute again 2a to each one of these terms. So 2 times 5 is 10. A times a cubed is a to the 4th. 2 times negative 6 is negative 12. A times a squared is a to the 3rd. 2 times 2 is 4. A times a is a squared. 2 times negative 3 is negative 6. There's no variable, so that's just a. So there's my first distribution. Moving over to my next distribution, I have negative 5 times 5 is negative 25. That's a cubed. Negative 5 times 6a squared is a positive 30a squared. Negative 5 times 2a is negative 10a. And negative 5 times negative 3 is a positive 15. Whew, we got a lot of terms there. So much, so many terms. What do we do? Well, that's actually very easy. You've gotten all your multiplication out of the way. At this point, you have to look for your like terms. Combine your like terms. This is where it's very important to use that strategy we mentioned before. You want to identify your like terms. You could use highlighters if you wanted to, if you're that kind of person to use highlighters. You could use underlining, which is what I do. Some people box and do different shapes, and that's okay too. Whatever strategy works best for you, use it. But as you go through, you might want to write down what you're doing and then cross off once you've combined those terms. I'll show you how we're doing that in this problem. Here I have an a to the 4th term. I don't see any other a to the 4ths in my problem, so I have 10a to the 4th. I've used it, so I crossed it off. A cubed. I have an a cubed here. I have an a cubed here, so I'm going to put a first underline there. Negative 12, negative 25 is a negative 37a cubed. I've used those, crossing them off. 4a squared and 30a squared, double underlining those. So 4 and 30 is 34, a squared. I've used them, so I'm going to cross them off. I'm looking at a squiggly line now, so it's just a and just a. So I have negative 6, negative 10 is a negative 16a. Cross them off. I don't see anything else over here, so I'm left with 15. So plus 15 is what I'm left with. And if you want to cross that one off, you've used it. There you are. Now, you know nothing else here will combine because you looked as you went through this process to combine like terms. Therefore, you are done with a very long polynomial, but that is A-OK. A because it had A in the problem. All right, that being said, this is a tedious process, and it can get very cumbersome as you're going through the individual multiplication steps, rewriting the problem over and over, but make sure you take your time. And I do suggest writing every single step. That way you don't lose something in the process. All right, I am going to erase this problem because we need the board space. This one took a lot of board space for me. We're going to do one more example to conclude this section. So, my next example, there we go. I'm writing too fast. My marker is not showing up. So I have x cubed plus x squared plus x plus 1 is my first polynomial. And my next polynomial is 5x minus 3. So I have a 4-term polynomial against a binomial term. Oh, there we are. So again, I'm going to distribute. And so this distribution is going to be a little bit long, just like the last problem, but that is okay. So I have 5x times my polynomial minus 3 times my polynomial. At this point, we need to multiply our individual monomials times our polynomials here. And let's see what we get. So 5x times x cubed, I get 5x to the 4th. 5x times x squared, I get 5x cubed. 5x times x, I get 5x squared. 5x times 1, I get 5x. That finishes the first part. The next part, I have a negative 3 times x cubed is negative 3x cubed. Negative 3 times x squared, negative 3x squared. Negative 3 times x is a negative 3x. Negative 3 times 1 is a negative 3. Combine your like terms at this point. This is the only x to the 4th that I see in the entire problem. So I have 5x to the 4th. Cross it off. I have an x cubed and an x cubed, so that's my first underline. So 5 and negative 3 is a positive 2x cubed. I've used it, so I'm crossing it off. I have an x squared, another x squared, so I'm going to double underline those. 5 and negative 3 is a positive 2x squared. I've used them, so I'm crossing them off. I have 5x, negative 3x, so I'm using a squiggly line now. 5 and negative 3 is positive 2x. I've used it, so I'm crossing it off. I don't see anything that I've missed so far, but I have a negative 3 at the end, so I'm bringing it down. Cross it off. I've used it. And there is my simplified polynomial. Now, again, working through polynomial multiplication can take a little bit of time because there is, as you can see with bigger polynomials, lots of little individual steps. But the key is distribution will work every time. And as long as you take your time, write every step, you are perfect. Just go through, double check your math as you're working. Once you get down to combining like terms, again, use a strategy to identify those like terms and then combine them. Once you've combined them, I suggest just cross them off your list like we have throughout this process. That concludes this section. I will be continuing into section 5.4 in the next lecture.